For this lesson, we're going to be looking at set theory. The learning outcomes for our Math 1332 course include apply the language and notation of sets. So this is going to be our lesson on sets, and at the end of this video, I'll be showing you some practice exercises that you can expect to see on our next test and on our final. So right now, you need to go into MyMathLab. You need to go to document sharing, and you need to print the set theory packet. Because as we walk through this, you need to write on it, mark on it, highlight, add sticky notes to it, but have some kind of document on which to put your thoughts and ideas. I have cut and pasted several parts from the Blitzer text, and the pieces and parts that we're going to look at are the following. So we're starting at what's called example 2, and it's how do you represent a set? Well, we're going to call them capital letters, and we're going to use braces. And then inside of our set, we're going to put items. So what we just looked at was listing all of the parts of our set. And here is another way that we can call or use. It's called set notation. We'll still start out with our capital letter and an equals, but when we get to the braces, we're going to say the words, the set of all. The set of all, the set of all x, and then when you see this vertical line, we'll say the words such that. And then the rest of it is going to describe what kind of things or items are in our set. So the part that you need to practice is when you see the squiggly line, you say the set of all, and you pronounce what's there, x, it could be y, w, all sorts of letters. The set of all x, such that, and then we'll pronounce what's going on behind. Like this is the set of all x, such that x is a day of the week. Those are the elements of our set. So a little bit more clarity, the roster method is going to actually list the items. So this is a set B, and inside the set B, you have George Harrison, John Lennon, Paul McCartney, and Ringo Starr. But the set builder notation would say B is the set of all X such that X was a member of the Beatles in 1963. So this is set builder notation, and this is roster actually listing it out. So now we're looking at the definition of what's called an empty set. It's also called a null set, and it has nothing in it, no elements. And there are two ways you can represent empty set. You can literally draw the braces and have nothing in it, or you can draw the 0 with a line through it. And going on, it says, notice that these have the same meaning. However, it is not a double whammy if you put the empty set inside of a set, because then it actually contains the element of empty set. So for empty set, you got to pick one or the other, braces with nothing in it or the symbol of empty set. And so here is an example, and the example is saying which one of the following really is an empty set. So looking at how do you recognize the empty set, which one really is of the following is an empty set. This one has something inside of it. This, well, and you can even look down here. The solutions are here with some more explanation. But like right here, this is a number. We're not even talking about a set. So don't be confused about 0 and an empty set. Empty set literally means there ain't nothing in it. And so if you look at part C, it's a set of all x such that x is a number less than 4 or greater than 10. Can we put something in here that's less than 4, like a 3, or that's greater than 10, like an 11? Sure, we can put stuff in that set. So this is not empty, this is not empty, neither is this one. And then if you look at this last one, we're going to put in here the set of all x such that x is a square with exactly 3 sides. Is there any possible way that we can have a square with exactly 3 sides? Well, no. So that's all of the squares with 3 sides. There are none. So the author of this textbook, Mr. Blitzer, He has a Blitzer bonus, and it's a really cool thing about John Cage, who is an American composer, and he did the quietest piece of music ever written. It's called 4 minutes and 33 seconds, and the musician sits frozen in silence at a piano stool for 4 minutes and 33 seconds. And the significance is 273 is approximately negative 273 Celsius, which is where all molecular motion stops. And so the set, as you see here, the set of all x such that x is a musical sound from 433 is truly an empty set. There are more notations. We have this symbol and this symbol. And so it starts by saying the first symbol is used to indicate that something is an element of the set. And I think of that as looking like an E, and that helps me to remember to say element. And the symbol E is used to replace the word is an element of. The symbol with a not sign through it is that it is not an element of the set, and it's used to replace the words is not an element of. So here is an example or a sample, some sample questions. Determine whether each statement is true or false. And then ask us, is R an element of A, B, C, D, E, F, G, H, all the way through Z? So is R an element of the alphabet? And that's true, it is. But then is R not an elephant? Wow, an element of 1, 2, 3, 4, 5. And that is true also. R is not an element is true. Moving on, the set of natural numbers. So you need to memorize when somebody says you have a natural number. I used to tell students in a class that we used to have, so I'll bring it back up here. It's what you do naturally when you're born or when you're starting to learn numbers. You naturally start counting. They're the counting numbers, 1, 2, 3. And N represents the counting numbers or the natural numbers. If you see 3 dots or the ellipsis after the 5, that indicates that there is no final element and that the listing goes on forever in this same pattern, in that there are no decimals, no fractions. We're going on forever in the positive direction. Here's another example. It represents sets of natural numbers and express each of the following sets using the roster method. So before I go on, I want to go back up to this one right here. That's not an R, it's a 7. My print is not coming out too well here. But 7 is not an element of 1, 2, 3, 4, 5. So it's still true. I just needed to go back and correct that. So now back down here to example 6. Looking at example 6, express each of the following in the roster method. So we need to list them out. So the set of A is the set of natural numbers less than 5. So we can't include 5, but natural starts at 1. So 1, 2, 3, 4. These are the ones that are less than 5. So we've listed all of the natural numbers less than 5. Next one, B. B, they want the natural numbers greater than or equal to 25. So we're allowed to start with 25 and equal to, and we can throw in a couple of more, but we cannot really list all of these, so we need to do our ellipsis and shut it down. Then we have the set E. It is the set of all x such that x is an element of the natural numbers, okay, and x is even. The set of natural numbers and x is even. And so 1 is not even, but 2 is. 3 is not, 4 is, 5 is not, 6 is. There's no ending to this, so we'll put our ... and be done. I just skipped past some stuff that's in your packet that you will not be responsible for, and I'm going down to definition of a proper subset. You need to know what's the definition of a proper subset. Any old set A is going to be called a proper subset of B, and it's going to be expressed with this symbol. And we'll say A is a proper subset of B if it's actually a subset of B and they are not equal, they're not identical. So A is a part of B, but they're not identical. That's called a proper subset. So a few more vocabulary that I'd like you to know. And the cool thing about a video is you can start and stop as needed so that you can ponder, think on, meditate on the concepts that are being talked about. So right here, we are going to talk about the thought that an empty set is a subset of every set. So the set of nothing is a subset of every set that exists. Furthermore, the empty subset is a proper subset of every subset except for itself, because technically they would be equal. So for any set B, the empty set is a subset of it. And for any set B other than, and I didn't see that line there, sorry. This one is this, which means it's a subset. And this one is just the proper subset. And so the first one is saying the empty set is a subset of any of our elements or any of our sets like B. But furthermore, the empty set is actually a proper subset of all sets except itself. Here's another concept where we're counting the elements. It says this is the definition of equivalent sets. The number of what's in set A and the number of what's in set B is what is going to be used for our definition of equivalent sets. So right here it says the number of elements in set A and the number of elements in set B equal 5. In other words, set A, the set of all X such that X is a vowel, A, E, I, O, U, and we won't get into the sometimes others. We'll just say that there are 5 elements in this set. And here, B, it says B is the set of all X such that X is a natural number, and it's less than or equal to 7, and at the same time greater than or equal to 3. So 3 is included, 7 is included, and all the naturals in between, and there are 5 elements. And so therefore, we see these lines that are arrows they have put, and it says that the sets can be placed in a one-to-one correspondence. Let's keep going. More information I'd like you to know is that if we define the set of United States Hispanics who speak both Spanish and English at home, and the set of United States Hispanics who speak neither Spanish nor English at home, let's talk about these two concepts. In discussing sets, it is convenient to refer to a general set that contains all elements under the discussion. And this general set is called, and you see down here, we're going to use a U, we're going to call it a universal set. And the universal set, and just kind of think about it, it's everything. It encompasses the universe. It is symbolized by U, and it is a set that contains all the elements being considered in a given discussion or problem. So a convenient universal set for the set described above is the set of United States Hispanics. So just a couple more thoughts on sets. There is another item called a complement of a set. Sorry, I just obliterated that. Let's undo that. The definition of the complement of a set, it is symbolized by A prime, and it's the set of all elements in the universal set that are not in set A. And this idea can be expressed in set builder notation as followed. The complement of A is the set of all of the elements of X such that the element is in the universal set and it is not in A. So going back to look at what we had earlier where it mentioned the set of Hispanics who speak both Spanish and English at home and the set of Hispanics who speak neither Spanish nor English at home. If our universal set is the set of Hispanics, then the complement of A, the set of all X such that the universal set is all Hispanics, and it wants us to also note that X is not an element of A. So if we're talking about the whole set, the whole universe, And we're talking about a piece over here like Hispanics who speak English and Spanish both at home. We want something that's in the universal set, but it's not whatever A is. And so let's let A be Hispanics who speak both English and Spanish at home. So if we don't want those, we want not those, then it's going to be the ones over here. And so if our universe consists of Hispanics who speak both Spanish and English at home versus Hispanics who speak neither Spanish nor English at home, neither Spanish nor English at home, then this would be our complement. It's in the universe, but it's not the other part. It is, we could loosely say it's the opposite. It's the other part. So in your packets, I'm going to skip over checkpoint 7 and go down to chapter summary, review, and test. In the very last two parts, you'll see our D and E, and they have these two symbols and these two comments. So the first one is this symbol, and the second one is this symbol. This first one is called an intersection. The other is called a union. And the way I remember them, union looks like a U, so that one's union, and the other one's the other thing. It's intersection. So union means or. We want everything that's in this set or in this set, and we're going to put them all together, and all of that goes in the new set. Intersection is an and. Whatever's in A and is in B, that's what goes in our new set for our intersection. So now let's go back and look at the checkpoint 7. So looking at your packet, go ahead and use sticky notes, markers, highlighters, definitely pencil, and let's talk about these one at a time. So the very first one, we need to do A intersect B. In other words, we're going to look at everything that's in A and everything that's in B, and it must be in both for us to be able to say intersect. Well, because of the drawing, this is kind of nice. I'm going to actually go ahead and write out A, the set A up here. It has 1, 2, 3, and 5. And the set B has 5, 7, 11, and 13. Now the whole universe has a little bit more in it where there's 17 and 19, but those are outside of our A and B. And so when we're asking this first one, A intersect B, what do they have in common? And the only thing that these two have in common is a 5. So what's in our set? Well, just a 5. Again, hit pause, think on this, play around with it. Even now, go for part B, and then come back and let's do it together. So part B, I'm going to work inside out. The inside part says, let's take A intersect B. Well, A intersect B, we already have it. It's 5. But it doesn't want just that. It wants the complement of that. So it's like the opposite. It's everything else. It's in the universe, but it's not what we just found. So what we need to do is the new set is going to be the complement of A intersect B. So if A intersect B is 5, then everything else is what goes in, not 5, our set. Moving on. Part C. Part C says let's find A union B. So I'm going to go back up here to our sets where I wrote out what A is and I wrote out what B is. And remember, use just a big old happy party. It's anybody and everybody and anybody else, well, as long as you're in the universal set. And so looking right here, if it's anybody and everybody that's in A, well, A has 1, 2, 3, and 5. B starts at 5, so I don't need to write it again. And it has 7, 11, and 13. So A union B, that's everybody that you see there. Let's play a little bit more. D says it wants A union B, but it wants the complement of that. So now I need everything that's not in A union B. A union B has all of this stuff, all of this, all of this, all of this. What's not that? 17 and 19. I'm going to skip the next two. For your test and for the final, wow, let's write straight here. That would be nice. Clear those two out. For your test and for the final, oh, sorry, y'all. You need to know how to do these. So go on to the in-class exercises in your packet, and let's look at the very first one. It asks us to either fill in element or not an element to make sure each statement is true. I would know how to do this for the next test and for the final. So is 93 an element of this set or not? Well, 4 is going to go all the way up, and it's natural numbers, and it's going to go through 93 and be included. So 93 is an element of that set. Number 9, is D an element of this set? And yes, D is an element. It's part of that set. I would make sure you know how to do number 8 and number 9 for the next test and for the final. So the next ones are asking about sets and not sets. I'm going to skip those, and I'm going to go on down to number 33. So looking at 33, it asks us, what's A intersect B? So I'm going to go up here, and I'm going to look at A, and I'm going to look at B, and I'm going to remember that intersect is everything that they have in common. And so to have everything that's in common, do they both have a 1? Yes. Do they both have a 2? Yes. Do they both have a 3? Nope. Do they both have a 4? Yep. Do they both have a 5? Nope. And so we now have A intersect B. So let's look at 34. 34 is, they want the set A to be union or united with the complement of B. So I'm going to go ahead and jot down that the set A is 1, 2, 3, 4. And then they're asking for the union of that and what's not in B. So everything that's in the universal set but not in B. So 1 is, 2 is, 3 is not in B but in the universal set. 4 and 5, those are in the universal set. 6, 7, and 8 are in the universal set but not in B. So if it wants us to take the set of A and unite it with the complement of B, or what's not in B, then now the union would be all of these together, no overlap. Everything that's in one that's in the other. So 1, 2, 3, 4, 3 is already there. So put in 6, 7, and 8. And this would be the union of A and the complement of B. Make sure you know how to do 33 and 34 for the next test and for the final. So this concludes our lesson on set theory. Check your syllabus to see if you have more assignments to do. If not, do a happy dance, and I'll see you either on video, in class, online. I'll see you somewhere. Bye-bye.